Hi friends, I am Balaji Rao. Welcome to BR Max class. This is 6th class based on formation of differential equations. And this is the last class on formation of differential equations. In this class, we will learn two problems based on formation of differential equation. First problem is form the differential equation of family of circles. Second problem is form the differential equation of family of hyperbolas. Okay, now you see this one, form the differential equation of family of circles. We need to form a differential equation of family of circles having center on y-axis. That family of circles having center on y-axis and radius is 3 units. To form a differential equation, we need to write equation of this curve. So first I'll try to write what is the equation of that curve. I'll draw a diagram here to write the equation of a curve. You observe here, from the family of circles, I considered one circle. One circle is enough to write its equation. I consider a circle whose center is on y-axis. You observe here, the center of this circle is on y-axis. And they mention that the radius of this circle is 3 units. That means this length they already given. Radius of the circle is 3 units. Generally, what is the equation of this circle? We learn this from circles chapter. X minus h whole square plus y minus k whole square equal to r square is the equation of the circle whose center is h comma k and radius is r. Here, as center lies on y-axis, if center lies on y-axis, we know that if any point lies on y-axis, its x-coordinate is 0. If we take center is h comma k, here h value is 0. So what is its center now? Its center is 0 comma k. Here k is the variable. Now what I'll do, I'll write the equation of family of circles whose center is on y-axis and radius is 3 units. You see, the equation of family of circles whose center is 0 comma k and radius is 3 units. What is that equation of circle? See, this is the equation of a circle whose center is h comma k. Here center is 0 comma k. That means h value is 0. So x minus 0 whole square plus y minus k. K is k only. Y minus k whole square equal to, by seeing this equation I am writing here, equal to r. R means radius of the circle. Here what is r? R is 3. 3 square. I'll simplify this little bit. See what you will get, x minus 0 is nothing but x square plus y minus k whole square equal to 3 square. 3 square is nothing but 9. What happened? We got the equation of this circle whose center is 0 comma k and radius is 3 units. Now we need to form a differential equation. To form a differential equation, we always remember 3 points. What is that? From the equation, you identify how many arbitrary constants are present in that equation. How many arbitrary constants are present, that many times we will differentiate. In the process of differentiation only, we will try to eliminate arbitrary constants. After differentiation, arbitrary constants are eliminated, well and good. Otherwise, we will use this third step. We will use any one of these things to eliminate arbitrary constants. You observe here how many arbitrary constants are there. You see, you don't think that 2 is arbitrary constant. 2 is a fixed constant. What about k? We know that k is a constant, but we don't know what is its exact value. That's why k is known as arbitrary constant. Here 2 is fixed constant. 9 is fixed constant. So in this equation, how many arbitrary constants are there? Only one arbitrary constant is there. So how many arbitrary constants are there? That many times we need to differentiate. In this, only one arbitrary constant is there. So we can differentiate this only one time. You differentiate this with respect to x on both sides. D by dx of x square plus y minus k whole square. I am differentiating this equation with respect to x on both sides equal to d by dx of 9. Okay. So derivative of this expression is what? That is nothing but d by dx of x square plus derivative of this term plus derivative of this term, d by dx of y minus k whole square equal to 9 is constant. We know that derivative of constant is 0. Derivative of x square with respect to x. We learned this in differentiation chapter. Derivative of x square with respect to x is 2x plus derivative of y minus k whole square. See here, I'll write d by dx of y minus k whole square. We learned this in chain rule differentiation. What you will do, you imagine, this is the trick. You just imagine this as x. it looks like x square. Derivative of x square is 2x. That means this is 2 into y minus k into which one you imagined as x, you need to differentiate it. That means dy dx of y minus k. So what you will get here, this is 2 into y minus k into dy dx of y minus dy dx of k. Dy dx of y is what? That is nothing but dy by dx minus derivative of constant is what? Derivative of constant is 0. So what is derivative of y minus k whole square? 2 into y minus k into dy by dx. So here I will write dy dx of y minus k whole square is 2 into y minus k into dy by dx. dy by dx I will write it as y dash so that a simplification looks good. So what I will do here 2 is there and here also 2 is there. You take 2 common and take that 2 to the right hand side. 0 by 2 will become 0. That means here 2 will get cancelled. Okay. Now one time differentiation is over because only one arbitrary constant is there. We cannot differentiate this second time because only one arbitrary constant is present. Now I need to eliminate arbitrary constant. How I will eliminate arbitrary constant? After differentiation, arbitrary constant is not yet eliminated. So we will use the third step. We will use the given curve here. See, from this we can write y minus k. Y minus k whole square is what? Y minus k, I am not writing whole square here. Y minus k whole square is 9 minus x square, correct? If you apply square root on both sides, then you will get y minus k. So x plus, in place of y minus k, I can write square root of 9 minus x square into y dash equal to 0. This is the required differential equation because in this no arbitrary constant is present. If you want textbook answer, you do little bit of simplification of this. See, you take this term to the right hand side, what you will get? X equal to minus root over 9 minus x square into y dash. Okay, so you square this on both sides. If we square this on both sides, this side you will get x square. When we square on both sides, this minus will become plus and the square root will get cancelled into y dash square. Okay, so this is the required differential equation for the given curve. Now we will try to understand this with one more problem. Form the differential equation of family of hyperbolas having foci on x-axis and center at origin. You see here, this foci is on x-axis and center at origin. To form a differential equation, first we must know the equation of family of that hyperbola. In Hyperbolas chapter, we learned that equation of hyperbola is x square divided by a square minus y square divided by b square equal to 1. If the family of hyperbolas having foci on y-axis, then the equation of hyperbola is x square by a square minus y square divided by b square equal to minus 1. But for this problem, the family of hyperbola having foci on x-axis center at origin, then the equation of hyperbola is x square divided by a square minus y square divided by b square equal to 1. If the foci lies on y-axis, then also the procedure is same. So first I'll write the equation of family of hyperbola whose foci is on x-axis and center at origin. What is the equation of hyperbola? The equation of hyperbola is x square divided by a square minus y square divided by b square equal to 1. Okay, now we need to form a differential equation from this curve. To form a differential equation, we will remember 3 steps. What is first step? Number of arbitrary constants present in the given equation. We will identify number of arbitrary constants present in the given equation. That many times we will differentiate. In the process of differentiation, we will try to eliminate the arbitrary constants. After differentiation, if arbitrary constants are eliminated, well and good. Otherwise, we will go to the third step. We will use dy by dx or given curve or d square y by dx square. You observe here. First, I will identify number of arbitrary constants present in this. How many arbitrary constants present in this equation? We know that a is a constant. We don't know what is a exactly. So a is a arbitrary constant. Similarly, b is also arbitrary constant. Don't think that 2 is a arbitrary constant. 2 is a fixed constant. We know 2 is a fixed number. Here a is a constant, but we don't know what it is exactly. So in this equation, how many arbitrary constants are there? two arbitrary constants are there. Our main intention is we want to eliminate those two arbitrary constants. As two arbitrary constants are present, we can differentiate it two times. First, I'll differentiate this with respect to x on both sides. I am just differentiating with respect to x on both sides. D by dx of x square divided by a square minus y square divided by b square equal to d by dx of 1. Okay, d by dx of x square by a square minus y square by b square. How we differentiate this? We differentiate each and every term. Derivative of this term minus derivative of this term. Derivative of this term, here 1 by a square is constant, you take it outside, into derivative of x square with respect to x is 2x minus derivative of this term, here 1 by b square is constant, you take it outside. Derivative of y square is 2y. As we are differentiating this with respect to x, the function is in terms of y. Here we will write dy by dx equal to derivative of constant is what? Derivative of constant is 0. Okay, so here one time differentiation is over. You observe here 2 is there, in this also 2 is there. What I'll do here, I'll take that 2 common and take it to the right hand side. 0 divided by 2 is 0 only. So what happens? This 2 will get cancelled. So what I'll do here, 1 by a square into x. I'll take this term to right hand side. This minus will become plus 1 by b square into y into dy by dx. I want to write all constants at one side. So what I'll do, you see here this x I'll take to this side. You take x to this side and b square to this side. What you will get? B square divided by a square equal to, take x to this side, y by x into dy by dx. I just written all constant at one side because our main intention is I want to eliminate arbitrary constants. As two arbitrary constants are present, we can differentiate two times. So one time differentiation is over, we got like this. Now what I'll do, I'll differentiate this again with respect to x on both sides. As we can differentiate two times, d by dx of b square divided by a square equal to d by dx of y by x into dy by dx. Okay, so b square by a square is constant. Derivative of constant is what? Derivative of constant is 0 equal to, you observe here product rule, d by dx of uv. What is product rule? We learned this in differentiation chapter. U into derivative of v plus v into derivative of u. So first u means y by x into, see, d by dx of dy by dx. I'll write here, you observe, d by dx of dy by dx is what? It is nothing but d square y by dx square. This can be written as y double dash. It looks good. So here what I'll write, dy by dx of dy by dx, that is nothing but y double dash plus v. V means what? dy by dx. dy by dx means y dash into d by dx of y by x. I hope you are understanding. I just applied product rule to this part. Okay. So if we simplify this further, what you will get? 0 equal to y by x into y double dash plus y dash into, see here, u by v formula. We learned this in differentiation chapter. d by dx of u by v is what? Is v into u dash minus u into v dash divided by v square. Okay. So here this is u and this is v. What is u here? U is y. What is v? V is x. Okay, you just differentiate v x into u dash d by dx of y. d by dx of y is nothing but y dash minus u. U means y into v dash. Derivative of x with respect to x is 1 divided by v square. What is v here? V is x square. Okay, you observe here in the denominator part x is there, here in the denominator part x square is there. If we take LCM is x square. X in this x square, x times. So what you will get here? You will get that xy into y double dash plus x square in x square one time. That means this part we need to write it as it is, right? So I'll multiply this numerator part with y dash. Then what you will get? x into y dash whole square minus y into y dash. You take this x square to this side, then what is remaining? This expression is remaining, that I'll write xy into y double dash plus x into y dash whole square minus y into y dash equal to 0. This is the required differential equation of family of hyperbolas having foci on x-axis and center at origin. We will follow the same procedure for differential equation of family of hyperbolas having foci on y-axis and center at origin. I hope you understand this class.